Hello, dear friends. Next, we will discuss the concept of parallel vectors. So, what is the definition of parallel vectors? Suppose we have two vectors u and v. These are two vectors. We say that these two vectors are parallel if one vector is scalar multiple of the other vector. For example, u is equal to kv vector or v is equal to ku vector. It means that u vector is equal to k times v vector, or we can reverse this concept as v vector is equal to ku vector. If u is equal to kv vector, then u and v are in same direction if k is positive, and u and v are in opposite direction if k is negative. So parallel vectors means two vectors are parallel if u is equal to kv or v is equal to ku. If u is equal to kv, then u and v are in same direction. If k is negative, then u and v are in opposite direction. This is same as we have discussed a multiplication of a vector with a scalar number. So this is simple concept like we have discussed above. Next we study addition of two vectors. So what do you mean by the addition of two vectors? Addition of two vectors is done in two ways. First one is known as triangle law of addition, and second one is known as parallelogram law of addition. So first thing is that what is the triangle law of addition of vector? So suppose we have two vectors a and b, represented by two side AB and BC of a triangle ABC. Suppose we have a triangle ABC. Here A is called vertex, B is also vertex, and C is vertex. AB is the length of a vector. A is the length of vector from here to here. This is the magnitude, and direction is from left to right, and below to above. This is vector B. And then if two vectors are A and B, then their sum is given by this third side. This is A plus B. uh, if two vectors A and B are represented by two sides AB and BC of a triangle ABC, such that the terminal point of A vector coincide with the initial point of B. Uh, Here is A vector, here is B vector, and if initial terminal side of this vector coincide with initial side of this vector, this is terminal side of this vector, and this is initial side of this vector. Uh, then the third side, this side from A to C, gives the vector sum which is AB. Now look at this, we are saying that this is vector A, this is vector B. The head of the this vector coincide or meet with the tail of the second vector, then their vector sum is given by A plus B, or in simple words we can say that AB 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 plus BC, this is equal to AC vector. So this is known as triangle law of addition of vectors. This is one way to find the addition of two vectors. The second method is parallelogram law of addition of vectors. Here consider a parallelogram, that is AB. We can name it C or D, but here let us discuss it. If two vectors u and v are represented by two sides AB and AC of a parallelogram, this is a parallelogram, this is side AC, this is side AB. Two vectors, u is putting here and v is putting here. Two vectors u and v are represented by two sides AB and AC. This is side AC, this is side AB. These two vectors are represented by the sides of a parallelogram. Then diagonal gives the vector sum. In that case, this is diagonal. This is diagonal. This will give us vector sum. In case of triangle law of addition of vectors, the third side will give the vector sum. But in case of parallelogram, the diagonal gives the vector sum. So this is the difference between the definition of parallelogram addition of vectors and that of triangle law of addition of vectors. Now we discuss the concept of position vector. What is position vector? This is very easy. Suppose this is our xy plane, this is our positive x-axis, this is negative x-axis, positive y-axis, negative y-axis. Here is the origin, here is point P in the plane. So this vector OP, here is the point O, this is the point P. So we can define this vector as OP vector. So the vector whose initial point is at origin, it means that a vector which can be described uh, with origin, from origin, its origin is this x-axis point, then this is called position vector. The vector whose initial point is origin O and the terminal point is position is P. This is its initial point, this is its terminal point, so this is called position vector, and we can write is OP vector. Next is vector in plane. Vector in plane, how can be represented? Let OP vector is A. We have already defined this is our position vector. We are denoting this vector by a simple letter A. So this is our A vector. We resolve A. X and Y be the horizontal and vertical components of respectively. Note that we have a triangle like this. This is the right triangle, and this length from O to this point is X, and from this to this point is Y. Note that this is a vector X and Y with the horizontal and vertical. So this is our horizontal and this is our vertical. Uh, Addition means, suppose we have a vector A which is equal to x1 y1, and we have a vector B which is equal to x2 y2, or we are adding these two vectors. These have two components, so we are discussing the vectors in plane. So we discuss the addition of two vectors x1 y1, x2 y2. So x1 plus x2, y1 plus y2. Here we are adding these two vectors, a vector and this is b vectors. So a minus b is equal to x1 y1, x2 y2. In simple words, we can say that whenever we are adding two vectors, then its x component will be added to x component and its y component will be added to y component. Similarly, in case of subtraction, its x component is subtracted from x component and its y component will be subtracted from y component. Next is the magnitude of a vector in plane. Magnitude of a vector in plane, what does it mean? This is very simple concept. Suppose we have positive x-axis, negative x-axis, positive y-axis, negative y-axis. So A is a vector in plane as shown in the figure. Pythagoras theorem is defined on a right angle triangle. It will say that the sum of length of hypotenuse is equal to sum of square of length of other two sides. So here is the, this is base, this is perpendicular, and this is our hypotenuse. So according to Pythagoras theorem, we will say that this is a hypotenuse scale, this is base scale, this is perpendicular scale. So hypotenuse is A, putting the value of hypotenuse, base is this one, and perpendicular is this one. So A magnitude square is equal to x square plus y square, and we have read that we can denote this magnitude by removing this arrow and these two lines. So this is simple A. So taking square root on both sides, and we have here a plus minus sign, but we can know that this is the magnitude. Magnitude means length, length means norm. So this can never be negative. So we can write this as positive. So this is the magnitude of a vector, and this is easy to understand the concept of negative, or sorry, magnitude of vector in plane. Another notation for the representation of vectors in plane is that let we have two vectors, one is O and other is OB, and a unit vector. Unit vector means a vector whose magnitude is equal to 1. So we will discuss it.